In this video, I want to see if I can come up with a clue about what the derivatives of the sine and cosine function are by analyzing their graph in Geogebra. In the last video, we calculated the derivative of the sine function. And so for sine, this will be just kind of a verification of that fact. For cosine, we'll see if we can learn something new about it. So I want you to do this along with me. So what I'm going to do is I'm going to show you the little chart that I've got set up right now. So what I've got here, and you should pause this video and make a copy of a chart like this for yourself. So we're calculating at a bunch of different angles here. So when theta is equal to 0 radians, when it's pi over 6 radians, which is the same as 30 degrees, I've got it for pi over 4 radians, which is the same as 45 degrees, and then finally at pi over 2 radians, which is 90 degrees. And so what I'm going to do is for each one of these points, I'm going to calculate what the sine of theta is by looking at the graph. I'm going to look at what the slope of the tangent is at that point of x, and then I'm going to do the same thing for the cosine function. All right, and let me go into Geogebra, and I'll do this for one of the points to give you a sense of what it is that we're looking at. So share screen. All right, so here we are in Geogebra, and the green curve here is the sine function. You can see my definitions over here. So my green curve is the sine function, my blue curve is the cosine function, and then the 3 points of x that I was interested in, pi over 6 radians, pi over 4 radians, and pi over 2 radians, are these vertical red lines. All right, so let me do the pi over 6 example. So I'm going to zoom in on this red line. And ideally, I'd like to do it in such a way that I can get it to pretty close to a grid line. So that's fine. So the value of sine of x is right there, it's 0.5. And the slope of this line, let's see if we can find another grid point here or something that's close to a grid point. That's pretty close. All right, so starting from this point to where the red and green line intersect, let's count to see what the slope of this line is. So we're up 1, 2, 3, 4, 5, 6, 7, and we're over 1, 2, 3, 4, 5, 6, 7, 8 and a little bit. All right, so we'll estimate that at 7 over 8 as that slope. Okay, and now I will press the home button to zoom back out. And now I'm going to zoom in on where that red line of pi over 6 intersects the cosine function. All right, that's close enough to a grid point. So here, the y-axis, so the cosine of pi over 6, I see is 0.866. And the slope of this line, let's see, there are a whole bunch of different grid points here. So let's just use this one. So we're moving down 1 and over 2. Down 1 and over 2. All right, and once again, I'll zoom out. All right, so let me show you what I've got written on my, chart at the moment. All right, so the sine value was 0.5 and the slope was 7 over 8. So I'm going to get out my calculator. Well, I'll just write that as 0.875. Okay, so that took a little bit of math. I could use my calculator for that, but I just happen to know what 7 over 8 is. And so I've got that for and the same thing with the cosine function. So what I'd like you to do is I'd like you to do the same thing for the remaining lines in this graph. So go make a GeoGebra sheet that looks like the one that I've got right here. So just to go back to that, so you need a function for y equals sine of x, you need a function for y equals cosine of x, you need vertical lines, x equals pi over 6, x equals pi over 4, and x equals pi over 2. And you can just write pi as just the word pi. So that's what it takes to write x equals pi. And so you can see that that line popped up right there. So those are the other two red lines are at the pi over 4 and pi over 2. And you can just look at the y-axis itself to find the values when x is equal to 0. So pause the video here, and then we'll take a look when the tone ends. Okay, so here's the lines that I have in my chart. So share screen, we're going to go back to the document camera. All right, and so the question is based on, remember that we said in the video where we determined that when the function is sine of x, the derivative of the function is cosine of x. Let's see if that bears out. So here, the slope of the function of sine is the same as the value of the cosine. And these are just estimates, but 0.875 and 0.866, and at pi over 4, we estimated the slope at 0.7, and the value of cosine theta is 0.707. And then at 90 degrees, we have the slope was 0 and the cosine of theta is equal to 0. So that looks like it checks off. Let's take a look at this chart and see if we can figure out what the derivative of the cosine function is. Because over here, we can see that the cosine values are a lot like the sine value. So 0 and 0, that would be 0.5, which is, I'm sorry, negative 0.5. This is negative 0.7, and this is 0.707, and this is negative 1 and positive 1. So it looks like there's this connection between the cosine, the derivative of the cosine and the sine function, except that the derivative of cosine is the negative of sine of x. All right, and so if we wanted to, we could check this for a couple more values of x, or we can go back and do another round of trig manipulation and kind of prove it more formally that way. But either way, what we are convinced of, or what I'm convinced of at this point, is that we can see that this relationship between the sine and cosine functions is not just true from them being kind of phase shifts of each other, but they also have this relationship that their derivatives are directly tied to each other. So the derivative of the sine function is cosine, and the derivative of the cosine function is the negative of sine.